All right, in lesson 3, we're going to talk about isosceles triangles and the properties that go along with them. It's kind of basic, like a little easy to understand. We have two sides in an isosceles triangle that match each other. That's the definition of isosceles, right? Two congruent sides. Well, a thing with every triangle, not just isosceles, but we will talk about it a lot here. The angle that is opposite of a side, they're kind of related. So this, what I mean by that is like this number 3 in this corner. That's talking about this angle right here. This corner is opposite of this side, and they reflect each other. So maybe a little thought experiment. If you imagine that like the bottom stays the same, and then we make this angle smaller, well, we have to make this angle smaller by moving this line downward. I'd have to squish it like that. What would making a smaller angle here do for this side? It would shrink it because the pieces, the two sides that connect that, would be smaller. Same deal if I made this angle bigger, if I suddenly took this wall and expanded it, well, this side up here now would have to get bigger too. So all of this is to say that in isosceles triangles, you have two congruent sides, you also have two congruent angles, okay? These will always match each other. So here's some vocab. The sides of a triangle are called the legs. Those are the sides that are congruent to each other. The angle where the legs intersect is called the vertex angle. That is up here, that is number 1. The side opposite the vertex is called the base or the bottom. Okay, so we'll often try to draw our pictures where the base is on the bottom. It just seems easiest to do it that way. The sides opposite the vertex, sorry we did that, the angles along the base are called the base angles. Okay, so these base angles are the congruent ones. And that will be super important because when I draw my pictures, my base angles, my bottom angles will always be the two that I set equal to each other. Okay, and I explained this kind of, but here's like the formal view of it. The isosceles triangle. So what this is saying is if we have two sides that are congruent to each other, and this triangle, it's these two. If AB is the same as BC, then the base angles A and C are congruent to each other. That angle is the same as that one. And this is a familiar picture that we will draw a lot in this lesson. The opposite of that is true. If my angles in the bottom are congruent, then my sides have to be congruent as well. They have to be, okay? So I need to have two matching base angles and two matching sides in every isosceles triangle for the rest of the world. All right, example time. Find each measure. We need to zoom it in. I would love to zoom in. There we go. So here we have a picture very similar to the one we just had. Here, I have an isosceles with two congruent sides like that. Well, in the picture I just had, if those were congruent, my angles down here were congruent too. One is 68, therefore the other has to be 68. And then angle K, the one at the top, the one I'm missing, well, there's 180 degrees in a triangle. Take away the two 68s we have. We get 120, 136, that's gonna be 46. Okay, right? No, it's 44. I knew it sounded wrong. All right, over here. It's a good start when you get the first example problem wrong. Over here, now we have an isosceles. It's a little different. This side here matches this side here. So where are the base angles? Might be hard to see, but here's what I'm going to show you. There's two things we can do realistically, but I want to show something. So the angle opposite this side, to find its corresponding angle, like the angle that it pairs with, well, it's not the one it's touching. See, there's two angles on either end of this. There's this angle here and there's this angle here. It's the third one. So this side is paired with this angle. They are directly across from each other. They match up. The same goes for this one over here. It's two angles on either of its corners. That's not it, man. You have to go straight across. So my base angles in this one are this and this. Okay. That might have been confusing. Maybe we didn't grasp that visual. So you actually have the benefit. You can rotate your paper. You can take it and change it to make it look like that is in the bottom. I also have the ability to slowly rotate this lovely program. Is that even, where are we? Okay, that might be the closest I'm gonna get. So now we can have a similar picture from before where the base angles are on the sides. Here we go. Now I have my matching sides, and the bottom, this one is gonna match that one. Okay. So however you choose to do this, manipulate your paper or follow it the other way, you have to just know that the bottom angles, the base angles are gonna be your congruent ones. And that base might change. So you have to be willing to stay flexible. All right, now I have 106 degrees in my top here. Let's see, I know there's 180 degrees in a triangle, so let's take away the 106 and figure out that we have 74 degrees left to work with. I need both of these angles to have the same amount. So I have 74 or something, I need to split it evenly between two corners. 74 divided by 2, 37. So one is 37, so is the other. We will do that one a lot. Now we're throwing a side in the mix. Okay, here are my two angles that are congruent to each other. That means that the sides opposite them, or the sides pointed upward connected at them, are going to be the congruent ones. If this side's 12, that side's 12. And these are my 77 angles. Up here, I can figure out what that is. 180, take away 77, take away 77. That's gonna be 156, 26. All right, a little bit of algebra. So we have two congruent sides, this one and that one, which means their angles are the ones that are equal to each other. Take what you have, 4x plus 7, set it equal to 9x minus 33, and now we're gonna solve. Move the smaller x. Took from the left, give to the right needs to give something back. 40 equals 5x. Divide. So x is 8. Did it just want x? I need to go back to the directions. Find the value of each variable. So yeah, x is 8. That's all we had to do. Over here, okay, very similar setup. A lot of this might get a little boring doing the same thing over and over again. But it's important that we get the process, okay? We need to know what sides are congruent to each other. These angles match. 5x plus 9 equals 8x minus 30. Move the smaller variable, give something back. Divide. Same steps every time. The steps don't change. Okay, number 6 is a little bit different. Just a little bit. It already has told you that this corner is going to match that one. So notice in all my drawings, I never, when I drew the sides that are congruent to each other, I never connected my red dots here. I never went there. I always went away from them. So these two are the pieces that are congruent to each other. 15x plus 7 equals 23x minus 17. one. Very, very similar setup. Okay, those are my matching corners. Those two are the ones that are equal to each other. Therefore, this side and this side, that's the equal pair. Okay, so one page done, one page to go. Oh boy, now there are words. All right, we're gonna have to draw our own triangle for this one probably. Yeah, we do. So, in triangle RST, it gives you two congruent sides. That's important, that's the key feature of this problem. It tells you what the angles are worth. Angle R is that much, angle S is that, angle T is that. Find X and then go back and find the measure of each angle. Okay, we're gonna do this, but we're gonna do this the same way every time for all of these. I encourage you to do the same. Of course, you can choose your own adventure, but mine is probably the easiest. So, I need to draw an isosceles triangle. I will always draw it like that, always. Now, I need to figure out where to label. It said here that my congruent sides are RT and ST. That's this one and this one. That's how I always set it up. So now I need to figure out, I have three corners, I have three letters. Which one goes where? Do you see in the thing I highlighted, RT and ST, which one is doubled up? Which letter appears twice? It's T. That double up letter goes at the top. Where R and S go after that doesn't matter, as long as they go in one of the corners. Okay, so what I have here is RT is congruent to ST, wonderful. And all my setup always, I said these corners matched each other. So the corners that are gonna match each other look like red. It's not a very good red, it's like orange. R for here and S. Those were the two pieces that are gonna be congruent. Draw the picture to figure out which ones are congruent. 9x plus 2 equals 13x minus 18. All right, let's solve for x. I'm gonna move the 9. I'm gonna give something back. Same steps every time. You can do this. It's the same thing. X equals 4. Okay. Now we have to go back and we have to figure out how much every other angle is worth. All right. So, I know R and S are the same actually. I only have to figure out one of them because the other one should match it. If x is 4, 9x plus 2, that's going to be 9 times 4 plus 2. That's going to be 38. And if that one's 38, S is 38. Because that's how isosceles triangles work. T is the only one I have to figure out now. That's going to be 17 times 4 plus 1. And that's going to equal... Is it funny? Is it 69? Is that what it is? Is it the funny number? No, it's not 69. Also, I got that wrong. What? X is 5? Dude. I'm leaving it in. You probably caught it and you're probably mad at me right now. But I'm not recording this again. Gotta divide by 4. Remember when I said this was easy and you can do this? Turns out I need to listen to myself. All right, X is 5, man. X is 5. I would not have caught that. Would have done this whole thing, would have shipped it, it would have been fine. All right, fine. I need to redo my math up here. Ah, frustrating. Oh, no, my highlight's wrong. It's all gone terrible. It's all gone to pot. Highlight. All right. 9 times 5 plus 2. That's 47. So is that. Okay. And now 17 times 5 plus 1. That's 86. Okay. There is another way we could have done this though if we didn't want to do that. If we were confident, once we figured out how, what x actually is, if we were confident that this is 47 and that's 47, well, how many degrees are in a triangle? 180. So I really could have done 180 and then taken away the two 47s. And I could have got 86 that way. Okay. Totally an option. Some people might want to substitute it in. Others might not. In a new triangle, DEF, the base angle D is congruent to E. Okay, all right. A lot of other stuff is happening here, but we're gonna draw my triangle. We're gonna draw it the same way every time. In this triangle, this corner is congruent to that corner. And this side is congruent to this side, always and forever. Now, it tells me D is congruent to E. Those are the angles, those are these. It doesn't matter which one's D, it doesn't matter which one's E. That leaves F at the top. All right, now let's figure it out. DF is one of my congruent sides, and so is EF. DF, where's DF? This one. And where's EF? This one. Those two are the sides that are congruent. I don't need to go around and label every side. I could say that DE, well that's x plus 4, and I could say, okay, EF over here, that's 4x minus 8, and then over here, 7x minus 35. Totally can do this, but I don't need to if I just know. If I draw my triangle the same way every time, I know that these ones are congruent, then I can go find them. 4x minus 8 equals 7x minus 35. Divide x equals 9. Okay, all right, did we do it right that time? We have to check. Yes, we did. Okay. All right, what does it want from me? It wants side lengths. Well, the two side lengths are congruent to each other. So I only have to figure out one of these ones, and I know both of them. This one's smaller, so I'm going to go with that. 4 times 9 minus 8 is 28. Yes, again, now I'm checking my notes all the time. Yeah, 28. Okay, so that means that EF is 28 and DF is 28. Okay, now the trick we just did before where we took 180 and took away the two blue numbers, that's not gonna work because we're talking about sides here. The angles add up to 180, not the sides. The sides could be anything. The sides could be really, really small or really, really big. Think about like a Dorito versus a pyramid. Okay, they don't have the same sides. DE though, DE is the bottom. DE was x plus 4, so that's gonna be 9 plus 4, 13. In this triangle, I have two sides that match. Okay. So, in our last one, I draw the same triangle, I have the same bottom two corners, and that means I have the same sides here that are congruent. If I'm gonna label this, the sides are congruent, so I look for the letter that's doubled up. WX, WY, it's W, so X and Y go here. So my X and my Y are gonna be the ones that match each other. My X and my Y. X is here, Y is there. 5x minus 12 equals 7x minus 48. Same steps, move smaller x, give something back, divide, every time, never changes. Okay, go back in and solve. Let's see. This right here, 5x minus 12. 5 times 18 minus 12. That's 90 minus 12, or 78. So that's 78, and therefore the other one is 78. Now at this point, I can take 180 degrees and I can take away my 78 and my 78. Or I can go back, because this doesn't look that crazy, and I can say, okay, this last one was x plus 6. X is 18. Pick whichever way you want to do. Pick whichever way sounds easier. Last little bit here. Equilateral triangles. Remember, triangle is only equiangular if it's equilateral, and it's only equilateral if it's equiangular. Basically, all the sides need to be the same, therefore all the angles need to be the same. We talked at the very, very beginning of this about how an angle speaks to a side of a triangle. If that angle gets smaller, well, the side has to shrink. If the angle gets bigger, the side needs to grow with it to cover it. So if I have equal angles, I have to have equal sides. In this triangle, I have two angles that are the same. To figure out the last one, 180, take away the 60, take away the 60 to figure out that, hey, I have 60 degrees left. We also talked about how if you have an equiangular triangle, that all of the measures have to be 60. It's the only choice. It's the only way to evenly split 180 degrees. So C is 60. Hey man, this thing's equal angular, which means it's also equal angular. So if that's 9, this is 9, that's 9. Over here, okay, I got same sides. I got same sides everywhere. This one's 24, therefore that one's 24, and that one's 24. But that doesn't help me, because it only wants angle lengths. Oh no. What's the only way to split 180 degrees from 3 angles? 60, 60, 60, every time. Last one. Hey, it's equilateral, which also means it's equal angular. Okay, we've got a lot of stuff happening here. Maybe it's spooky, maybe it's not. I know every corner is worth 60. I just know that because that's a fact of these triangles. So this corner here is going to equal 60. 7x minus 3 equals 60. Add the 3. 7x equals 63. I believe that is 9. X equals 9. Excellent. Okay, one done. Now I need to figure out what y is. I'm guessing y is the sides, right? Yeah, I got a y over here, a y there, and a y there. So I got 3 sides. Pick your favorite 2, set them equal. All your sides are equal to each other. 9y plus 1 equals 11y minus 23. Smaller numbers. No reason other than that I picked it. Subtract 9y. Give something back. Should have picked maybe a different color than red. Oh well, in it now. 24 equals 2y. Y equals 12. Okay, you got this.